All right, so ladies and gentlemen, today we want to continue our efficiency analysis. Now, for your information, we have looked at some few things already. One, we have been able to notice that if you want to do efficiency analysis, the first step is to identify the decision-making unit, the organizations. And so we indicated that you have to select your industry. And this course is teaching you for the purposes of research. So there are practical information that I gave. So you select your organization. Your decision-making unit must be homogeneous in character. They must use similar inputs to produce similar output. And so if you don't have similar input and similar output, you can't say that you are homogenizing it. If you take, for example, secondary schools and then universities, they are not homogeneous in character. They are not homogeneous at all in character because secondary schools do not do publications, but universities do publications. And so it's very important to understand the difference between the two. Another thing is, apart from the selection of the organization, the next step is to determine the inputs and the outputs. And so if you have selected something like university, what are the inputs? Incoming students is an input. What are the inputs? Lecturers, or what we call academic staff. Then there's another group of staff which is known as administrative staff. So these are inputs. What is an input? Okay, somebody might say research grant. So these are the inputs, and the input must be cutting across all of the DMUs. You must cut across everywhere. Then we go to the outputs. The outputs are what? Outgoing students, which can be undergraduate outgoing students, master's degree outgoing students, PhD holders outgoing students. Another output could be the number of publications published by doctors and lecturers, professors. Okay, so that's another output might be investment, because the university might be doing investment. For example, some universities have university farms and they generate revenue from those. So the second step is selecting the input and output. And there's a whole bunch of literature on how to select input and output. So when you are selecting the input and output, how do you know that the input and output you are selecting is good? Well, look at the literature, especially the survey papers. The survey papers are those papers that have published multifaceted articles that coalesce them together. So let's take, for example, bank. The inputs are what? Who can tell me some of the inputs of a bank? Who can tell me? You either type it or you unmute yourself and say it. What are some of the inputs of a bank? Anybody? Yes.
Say deposits.
Deposit is an input of a bank. Now that is under the intermediation process. What else? What is another input?
So you can also have labor.
Labor, employees, or their salaries. Yes. What else?
Fixed assets.
Fixed assets. Very good. So you have labor, capital. Now, when you say capital, you have to distinguish. There are two kinds of capital. One is physical capital, which is a fixed asset. One is a financial capital, which is the equity. So you have to make sure clearly which one you're dealing with. Now, what about the outputs? What are the outputs of a bank? What are the outputs?
Doc, we have loans.
Loans, very good. What other output do we have?
So you have investments.
Good. So loans and advances, investment. So these investments, you have to be clear that it cuts across, because if you want to talk about total investment, you have to be clear that you're talking about total investment. Okay? Because sometimes some will declassify the investment. They will reclassify them actually. Some will say government bills, eligible bills, investment in associated companies, investment in that. And you have to be clear that that cuts across everywhere. Total investment. What other outputs are there? What other outputs? Banks. What other outputs? Well, if you want to be a little bit controversial, you may also separate corporate social responsibility. It will be one of the outputs. Well, as to whether it's an output or an input or an undesirable output is another thing. But it's one of the outputs. CSR. Another output people talk about is off-balance sheet activities. Off-balance sheet activities. That is another thing that one might actually speak about. Okay. What other outputs? What other outputs? If you don't take it, the only output you will know are those outputs. But then there are, if you look into the literature, so for banking like this, there are taxonomy papers. One of them is, and you want to note this down, one of them is by Humphrey and Berger. Quite an old paper, but quite useful, 1997, published in European Journal of Operational Research. Okay. Then there is Bauer, 1998. He's also published. Then towards the year 2007, Berger came back again and also wrote International Comparison of Banking Efficiency. He also wrote a paper. And then in 2010, Fetti and Pasiuras, written in European Journal of Operational Research, EJOR. Also, these are survey papers I'm actually talking about, papers that have surveyed the entire banking industry, banking efficiency and productivity industry. Okay. So 2010, he did that. Then in 2008, actually, there are some papers by Zhu that also did survey papers on the technique which I use as well. Then in 2015, Helges, okay, also did a collation of parametric and unparametric frontier analysis. That also has banking studies in it. So there are quite a number of papers that have been done in such areas. A number of other survey papers have been done. In fact, in 2020, there have been quite some survey papers on efficiency and productivity analysis. So when you look at that, good. Paradi and Zhu is another one, very good. Daniel for bringing that out. 2013 is another. In fact, Paradi himself from Canada and his group of people have done a lot of survey papers in banks and bank branches. So if you are doing studies on bank and bank branches, these papers are very, very important for you. The survey papers, the survey papers. Now, for those of you who are doing in insurance, Ellen, E-L-I-N-G, Ellen has done a couple of survey papers in insurance. Okay. And so you want to, Gaganis also has done a couple of papers, survey papers. When you read the survey papers, it stops you from worrying yourself with going for individual papers because you can get all the papers in there. So that is Cummins, very good. Cummins has also done a number of studies related to insurance. Cummins, very good. So now we are ready to rock and roll when it comes to the third step, and probably the most important step when it comes to efficiency and productivity analysis. So remember, step one, identify your DMU. Step two, identify your inputs and outputs. Step three, choose your efficiency type measure. And this is where it becomes a little bit complex, but actually it's the most important. So we're going to look at the third step. You have to determine the type of efficiency. And please, you want to take note of everything we're doing here. You have to determine the type of efficiency that you are dealing with. And there are different types of efficiency. Some of them contain some of them. Some of them contain others. Some of the efficiency types contain other. Okay, so for example, technical efficiency, inside it, you will have pure technical efficiency. Inside it, you will also have scale efficiency. Okay, then there is a scope economies. Scope economies. So you come to later realize that scale efficiency is different from scope economies. And some people misunderstood the two. Then there's another kind of efficiency, which is allocative efficiency. And then cost efficiency, also called economic efficiency. In the world of parametric analysis, parametric frontier studies, cost efficiency is sometimes called economic efficiency. Okay, cost efficiency is sometimes called economic efficiency. All right, so cost efficiency, actually cost efficiency is made up of, and you want to be taking notes on some of this thing. Cost efficiency is made up of the allocative times the technical. Cost efficiency is made up of the allocative times the technical. And the technical is made up of the pure technical times the scale. The same way, revenue efficiency is made up of the allocative times the technical. Profit efficiency is made up of two things. One, the allocative and the technical, or sometimes the revenue plus or times the cost. Actually, it's the revenue minus the cost. The revenue minus the cost. That is the profit efficiency. So we are going to look at each type of these efficiencies, and then you will know which one we are going to use. In fact, some of you are going to use technical. Some of you are going to use cost. Now, when you are using cost, what it means is that you'll be using both technical and allocative, and then split the technical into pure and then scale. Some of you will also look at scope economies, okay, and several others. So let's look at today the type of efficiency called technical efficiency. What is technical efficiency? And please remember to ask questions intermittently at any point in time. Well, the word technical efficiency was originally coined by, in the world of the DEA, it was coined by Farrell in 1957. And he used something we call the contraction of inputs. When you are contracting inputs, what it means is that you are reducing it. So if I can contract input, holding the output constant, or if I can augment output, augment here means increase. If I can augment output, holding the input constant, then we are talking about technical efficiency. So technical efficiency is the ability of a firm to reduce the inputs holding the output constant, or increase the output holding the input constant. Later on, you come to realize that the two of them can be done at the same time. So the two of them can be done at the same time means that you will reduce the inputs whilst increasing the output. And normally that is not easy to be done, but that kind of orientation is also there. So this is a definition by that. But before then, Koopmans and Debrew have given a strict definition of technical efficiency. And that strict definition is important. According to them, a firm is said to be technically efficient only if it operates on the frontier. Now, you might be wondering, what is the frontier? The frontier, we are going to look at it and draw it and understand it in total. Only if the firm is operating on the frontier, and furthermore, there are non-zero slacks. Non-zero slacks. Now, do you all remember linear programming? Did you all do something on linear programming? If you did, just type yes or just say yes. Okay, undergrads in particular, did you do linear programming? Okay, so you did linear programming. So in linear programming, you maximize an objective function subject to some constraints, you remember, or you minimize an objective function subject to some constraints. Now, the maximize here could be maximizing revenue or profit. The minimize here will be, okay, minimizing costs or time. Now, in this thing that you did, you will need some constraints, and these constraints are the necessary resources. That is if you are maximizing. If you are minimizing, then we are not talking about necessary resources. It also talks about those resource requirements. And so if you are, for example, producing fan yogo or fan choco, you will need inputs like labor hours and inputs like milk. Okay, labor hours of milk. So the labor hours of milk will be the input. But then there will be a limited inputs. The inputs are usually scarce. And so because they are scarce, they are limited. And so you could be told that the total number of hours available per week is 40 hours. So that means that you have 40 hours a week, and so you should be able to utilize all the 40 hours. Now, if you underutilize the resources, the 40 hours, let's say you utilize 30 instead of 40, then it means that you are left with some hours that you did not use. This leftover hours, this leftover resources is what is known as the slacks. The slacks. Now, Koopman is saying that if you are saying that you are an efficient producer, you should not have any slacks. That is the simple point he's saying. So for you to be truly, fully, beautifully efficient, you must have non-zero slacks. And that means that there should be no inefficiency. There should be no inefficiency, because the inefficiency, you can't say that you are efficient when you have some underutilized resources. And so the resources should be fully utilized for you to say that. So Koopman's definition is deeper. It makes efficiency very strict. Okay, but Farrell's efficiency definition is simpler. Okay, Farrell allows you to be efficient even when you have unused some of the resources. But Koopman says no, you should have all resources fully used. We shall dig deeper into technical efficiency. This is theoretical meaning, but let's go practical. We shall use the word radial to represent technical efficiency. So when we are saying technical efficiency, we shall use the word radial. Now, the word radial, you will come to better understand it, start drawing it. Okay, radial is when you are moving towards the origin. So whenever you are in a Cartesian plane, okay, let me see if I can draw something related to this Cartesian plane. Okay, let's say that you are in a Cartesian plane and you're in a Cartesian plane. Let me just showcase something here. So this is a Cartesian plane, right? The plus or minus. Let me clear it and do a better one. Okay, but I'm just going to use the positive signs, okay? The positive signs here, like that. So I'm forgetting all the negatives that are there, the negatives that are here. Please, do you see my screen? I'm ignoring the negativity. So this will be 0, okay. This will be 0. And then we are calling this the x-axis. And then we are calling this the y-axis, okay? All right. So if I try to move towards the origin, if I am moving towards the origin, the movement is said to be radial. And if I'm also moving from the origin, it's also called radial. So radial here is increasing something from the origin or reducing something towards the origin. I'm sure that's clear. Okay. Increasing something from the origin and then reducing something towards the origin. Now, let's move on and then look at the intricacies of technical efficiency. So I've already given you this definition that technical efficiency is the ability of a company, a DMU, a firm, an organization to reduce. And what is a reduction? The reduction is towards the origin, is to reduce. So that's why we say radially reduce, or we say proportionately reduce. Reducing all the inputs towards the origin. Because if I am able to reduce the inputs to zero and still produce an output, I am powerful. I am absolutely powerful. But of course, you can't reduce all the inputs to zero and expect to produce something. So the idea is to reduce all the inputs proportionately whilst maintaining the output. Whilst maintaining the output. Now that reduction is said to be input orientation because you are focusing on reducing the input. Or another definition is to expand all the outputs given the inputs. So you hold the input constant, you raise all the outputs, okay, given the input and the technology. And once your focus is on the increasing the output, then the orientation becomes output orientation. So, ladies and gentlemen, when you are doing your research, you have to decide which orientation you're going to be dealing with. You got to decide whether you're going to do with input orientation or output orientation or non-orientation. Non-orientation is both, okay? That one is where you reduce the input and reduce the output at the same time. That is non-orientation. Now, when we talk about technical efficiency, what do we mean, practically speaking? Yes, Daniel, you have a question. Raise your hand. Ask your question.
Hello, Doc.
Yeah.
I want to ask whether if you are estimating profit efficiency, which deals with both inputs and outputs and their prices, which opt for? Since we have inputs and...
You mean which orientation will you be dealing with? Is that a question?
Yes, Doc.
Yes.
Yes, Doc.
Doing cost efficiency, your goal is to reduce the cost. What cost? The input cost. And so the orientation is automatically input orientation. When you are dealing with revenue efficiency or profit efficiency, the orientation is automatically output orientation. Does it make sense?
Yes, Doc. Thank you, Doc.
But when you are dealing with technical efficiency, that is where you have to make a selection as to which of the three types of orientation you are dealing with, whether input orientation, output orientation, or non-orientation. We don't say both orientation, we say non-orientation. Okay, we shall look into details of this. Now, what is efficiency? Practically speaking this time. Efficiency has to do with, technical efficiency has to do with managerial acumen. And you want to understand here very carefully because when students and researchers write their papers, they are not able to connect the results to the technical words that they have used. They're not able to connect the results. They're not able to indicate clearly that this results, how it relates to managerial acumen. And I want you to know that if you have calculated efficiency, technical efficiency, and that calculation is 100%, what it means is that the managers have performed a 100% job in reducing the inputs and output, in reducing the inputs and raising the output. They have performed 100% work. The managers are good. The managers are, so technical efficiency is attributable to managerial expertise. It's attributable to managerial acumen, management ability to control. So when you go to a bank like this, the management team, we have the treasury department, you have the IT department, you have the operations department, you have the marketing department, the marketing manager, Okay? You have the, and then you have the CEO himself. So these individual managers, if there's anything good that is obtained via technical efficiency, it's attributable to them. It means that their performance is good. Of course, what it also means that if there's anything that is bad, we also attribute it to the managers. We don't attribute it to the employees per se, but we attribute it to the managerial performance. The ability of the manager, because the managers are the ones who are controlling. They fire and hire. They are reducing the inputs. And one of the inputs is labor. So they will tell you that labor is good or labor is not good. And that is a critical thing that is being discussed there. Okay. Any question on this? Because you are continuing. Now, there are three main kinds of efficiency that are inside technical efficiency. So technical efficiency is made up of three main kinds. We don't normally talk about one particular one, but I'll mention it though. It's called mixed inefficiency or mixed efficiency. You can use opposite. Mixed efficiency is efficiency due to correct composition of the inputs. Correct composition of the input, which means that mixed inefficiency is due to the incorrect composition of the input or the output. I'll give you an example. Let's say that you take deposit. How many deposits can be mobilized in a day? How many? How many deposits can two workers mobilize in a day? Maybe $10,000 of deposit can be mobilized in a day. And how many person can do that? One person can do that. So if one person can mobilize 10,000 deposits, what does that mean? It means that, relatively speaking, two persons can mobilize $20,000 deposit. Three persons can mobilize $30,000 deposit. Now, if you get three persons and they are not able to mobilize $30,000 deposit, what does that mean? What it means is that those three persons are not efficiently working. So it means that your ability in you including those three persons, your combining those three persons was not good. Your mix of the inputs was not good. So why don't you probably get one person? So let's say that the three persons are doing $10,000 mobilization of deposit, something which one person can do. So what you want to do is to fire the two people and allow one person to do the job. Your ability to mix the input, in this case, the workers and the deposit, your ability in combining the inputs and output, correct way of doing it is what is known as mixed efficiency or mixing efficiency.
Hello, Doc.
Yes.
I have a question. In that case, if we are to look at the market, because if we talk about, let's say, region, Greater Accra, and you send 10 people to raise deposits, and you send 20 people to, let's say, a region, one of the new regions, the likelihood of that 10 people in Accra raising high deposit is the possibility is high as compared to you sending even 50 people to any of the new regions. So in that case, if we are just to look at the output to determine the efficiency, won't we be making
yes. In this case, basically in this case, what you are doing is that you are bringing factors that are outside the employee's control into the picture.
Okay.
Now you can see that the region is outside employee's control. Is that correct?
Yes, Doc.
So they don't control the region. Now, anytime you bring something that is outside the control, then you have to look at the whole picture differently. So by talking about this deposit mobilization, we are assuming that the size is constant. The size of the region is constant.
Okay.
You get a picture?
Yes, Doc.
We are assuming that if this is 20,000 square kilometers, it's going to be like that for every single person. Okay. Well, of course, this is only an assumption which can be relaxed, and it's always relaxed, and that is possible. Okay. But this one, we are assuming that everything is under the control of the person. Okay. Now, so understand mixed efficiency or mixed inefficiency. The next kind of efficiency, which is inside technical, is called pure technical. Pure technical. Now, as the name sounds, it simply means that it is an efficiency attributable to the managerial performance alone, devoid of scale factors. I'll give you an example, very easy example for you to do. Which is one of the best universities in Ghana? Which is one of the best universities in Ghana?
University of Ghana, Lagos.
Good. Now, which is one of the best, presumably the best, secondary school in Ghana? Presec. Good.
Currently, Presec.
I know there's going to be challenge because people prefer some things. Okay. But let's say Presec, presumably. Okay, this recent brilliant science and math quiz, who won? Presec, isn't it?
Yeah, Presec.
Presec, good. Look at somebody is writing Holy Child. Okay. All right. The fact that you went to a particular school doesn't mean that that school should be the best. We are taking away subjectivity. This is being objective. Okay. So Presec actually won just the ended brilliant science and math quiz. Now, let's assume that a person goes to Presec and that person leaves the secondary school with aggregate 6. I mean, had all the grades to be A's. The person had 6 A's. Beautifully. Now, there are two possibilities. It could be that that person was not that much of a good student, but because Presec itself has a good name, good teachers, and good kind of publicity, the person that motivated the person to learn very well. Could that be a possibility? Is that possible?
Yes, it is.
Yes,
so the
Doc.
person could do well because Presec itself is known to do well. And the discipline that has been instituted in Presec, the person has no choice but to learn hard and to do well. So in this case, the person is leveraging on the scale of Presec. That's what we call a scale effect. So the person is not doing well, not because of his own volition. So for example, the person is doing well because the library itself is always filled with books. The person is doing well because the teachers themselves are well paid and they teach very well. The person is doing well because there are extra classes and there are lightning systems. That's it. Now compare that person to another secondary school, which is very, very far away in the village. Okay. Konkonsomia Secondary School. Now, this Konkonsomia Secondary School, they don't have a library. In the evening, there is no light. And yet that person also got what? 6 A's, all A's in the grade. All of them. One is from Presec, had all A's. Now, this guy from Konkonsomia Secondary School also had all A's. Which of them two would you say that did very well? The one from the Konkonsomia Secondary School, is that not true?
Yes.
But that is only because you dug deeper and you were able to detect that there were certain things in the structure, in the scale, in the size that affected. So when you come to realize, so a bank can be good, which is not attributable only to the managerial performance. the managerial skills. So the managers themselves will do well, but that is because the managers themselves are relying on the past glories. For example, if you look at ABSA, Barclays, okay, the firm in Ghana here might be doing well. The firm in Ghana here might be doing well because that particular Barclays bank or that ABSA in the UK is supporting them. It's supporting them with a lot of intelligence, a lot of acumen. And so that is how come they are doing well. But not because they themselves naturally do very well. So this is where skill comes in. So skill is something that is underlining your performance, but it is actually out of your control. So when we say pure technical efficiency, it is that efficiency of which you have control over. So if that guy in Presec does very well, because the library is good, because the teachers are good, the gentleman has no effect on the library, it has no effect on the teachers, and so those things are not under his control, and that is how come he did well. Okay. But if the individual person does well, even with a bogus system, even with a very bad system, managerial system, that person is not going to, we are going to say the person has done extremely well. So pure technical efficiency is that kind of efficiency attributable to only your own doing because of your own controllable impact. Okay. That is different from skill efficiency, which we shall look at. So later on, I'm going to mention skill efficiency, and that you will notice that the skill efficiency is that kind of efficiency that is attributable to not your performance, not the managerial performance, but the managerial performance as a result of the scale, the size of the firm, of the industry. Does that make sense? Does that make sense?
Yes, sir. Yes, sir.
And in order to distinguish pure technical efficiency from technical efficiency, you will estimate one of them by VRS, variable retention scale. And then another one, you will estimate it by CRS, which is constant retention scale. We shall look into the details of this. So I've spoken about mixed efficiency, pure technical efficiency, and I've also mentioned scale efficiency, but let's look at scale efficiency better. Let's look at scale efficiency better. Okay. Now, what is scale efficiency and what is scale economies? Some people say they are the same. Actually, they are more or less the same, but let's look at it slightly. So let's look at economies of scale. This is important. This is critical. This is important. And you want to fully understand this. If you are able to reduce the average cost, some of you remember the average cost, the U-shaped cost curve. If you look at the U-shaped cost curve, where you have the output on the horizontal line and you have the cost on the vertical line, and you look at it, as you move from the left to the right, along the U-shaped cost curve, you are reducing cost. So you will see that the cost will fall. The average cost will be falling, gets to the minimum, and then will start rising again. And this is normally attributable to the law of diminishing marginal returns. Okay. Now, the economies of scale is that falling average cost because of the increasing scale of production. So the more you produce, the more your cost falls. Why? Why is that possible? There are practical reasons. Okay. If you are producing more, the cost will go down. Take, for example, those who do buildings. Okay. Now, when you are trying to produce one building, you sometimes will buy the materials from Italy or from Germany or from another place. You buy the materials plenty. And that bulk purchase of the material will help you to do what? To cut down the cost. Is that true? Is that not
Yes,
true?
sir.
Yeah. They say
It's
bulk
true, though.
purchase is cheaper. And so you, instead of going to buy for one house and next time you go and buy for one house, if you buy it in bulk, it is cheaper. And so you are able to produce more, even though you are able to produce more, and yet your cost is falling. Your cost per unit, not just cost in total, your cost per unit is going down. And that cost per unit, when it's going down, even though you are producing more, is what is known as economies of scale. Okay. And it is that U-shaped cost function that we know in economic theory. Now listen, this is as a result of spreading the fixed cost over the larger volume. Of course, we know that as you are producing more, okay, you are using the existing fixed cost. So cost is fixed, and yet you are adding to the variable factor. Fixed factor, fixed cost. So the cost has already been incurred. The cost of the rental of the house has already been incurred, and yet you're able to use that to produce more. And that is economies of scale. Now, in our frontier efficiency analysis, and please take note, scale efficiency is derived from the ratio of the people behind the method, CCR and BCC. We shall look at them very soon, okay? Chance, Cooper, and Rose, and banker Chance and Cooper. Chance, Cooper, and Rose, we call them CCR. Banker Chance and Cooper, we call them BCC. Now, when you estimate the technical efficiency according to CCR, that technical efficiency is called technical efficiency. But when you estimate the technical efficiency according to BCC, that technical efficiency is known as pure technical efficiency. It's known as pure technical efficiency. So, watch something interestingly. If you calculate the technical efficiency, okay, if you calculate it, and if it is 1, if it is 1, then it means that we have scale efficiency. If it is 1, then we have scale efficiency. But if it is not equal to 1, or if it is less than 1, if the scale efficiency we calculate is less than 1, then we have scale inefficiency. And that means that the source of the inefficiency is due to the operating the firm at either increasing returns or decreasing returns scale. So if the firm is operating at the increasing returns or decreasing returns, then we have what? Scale inefficiency. Now, the question you might be wondering is, what is decreasing return? What is practically what it means by decreasing returns? And what do we simply mean by increasing returns? Well, decreasing returns will mean that the firm is too large. That's decreasing returns. Increasing returns, it means that the firm is too big. It's too small. And so these things will mean that the firm is too something. But constant returns, which is sometimes called economies of scale, it means that the firm is neither too big, nor too small. Well, we shall do a lot of calculations on this for you to understand, but try and understand that scale efficiency is part of technical efficiency, and it is efficiency attributable not to managerial's own performance, but the performance of the. So the key point of that is you have to detach, you have to decompose the efficiency into two for us to know which part is as a result of your own doing and which part is as a result of the size of the organization. So a gentleman does well in school, and you want to know whether he's getting all the A's is attributable to the school he went to or his own doing. And that is the essence of these two distinguishing different. I want you to now look on the screen. and then we will help you to better understand what we are. So before look on the screen here. Look on the screen, and you will see that on the screen now there are different ways of drawing the graphs we shall be drawing. This is just a graph, but you guys will draw a normal, graph on your own. There are three kinds of graphs. And let me just go back here and then quickly sketch the three kinds. The first one is this, where you have the input and then the output. So this is where you have one input, one output. And when you draw the graph is like the normal production function. It goes here, and it goes here, and then it goes there. And then you have the individual firms all inside it. Some are on the firm, and some are inside the firm. There's a second graph, which is input-oriented graph, which means that the input is X1, and the other input is X2. Now, when you're drawing this graph, it goes something like this. It becomes a kind of a concave graph, an isoquant, the general economic theory idea of isoquant. So this is sometimes called isoquant. And this one is a production function. Now you can see that I'm drawing them by lines instead of drawing them by smooth lines. Okay. I'm not drawing them smoothly like that. No, I'm using piecewise, and you will understand later why that is so. So I want you to take note of these three graphs. Okay. The last one is output graph. So where you have Y1 there, and then you have Y2. And the way the graph is concave. Okay, that graph is concave like that. Again, you have the firms, the input, the DMUs, and all of them has gotten an origin. So these are the three different kinds of graph that you want to take note of. Those three different kinds of graph. The question is, why do we have them? Well, sometimes 2D diagram is easy to draw. Okay. 2D diagrams are easy to draw. Now I want you to go back here. And look at the graph that we have here. Look at the graph very carefully. And when you look at the graph, what kind of graph are we looking at? This is the isoquant kind of graph. And on the right side here, what kind of graph? It is a production possibility kind of graph. Now, carefully look at it, carefully. Now, you can see that there is one straight line that I've drawn from the origin to letter E. It's like a 45-degree line between the input and the output. That line is called constant returns to scale. Okay, so this line is called constant returns to scale technology. We shall deal with it deeply. Then there is another one which starts rather from G, it goes to B, passing through J, from B it goes to A, from A it goes to H. That graph is known as VRS graph, variable returns to scale graph. Variable returns to scale graph. The technology that is underlining these graphs are different. Now, we will learn how to estimate efficiency, and you will see how we can use estimation of efficiency to distinguish between all the different kinds of efficiency that we have mentioned, using these graphs one by one. Okay, using these graphs. But I want you to know from here the different kinds of graphs that we have. Let's go to another kind of efficiency or economies that we normally talk about, which is known as scope economies. Scope economies is different from scale economies. I want you to please know the difference. Scope occurs when the firm specializes in a narrow range of products. If you look at the word scope, you focus, that's it. Sometimes we call it focus. So some of you will be looking at banks that are focus banks, specialized banks, and banks that are diversified, universal banks. That's a typical example. Now, it is believed, some theories believe that if you focus on one thing at a time, you do very well. So they propose this economies of scope. And so economies of scope refers to the cost reduction that you gain if you produce a variety of outputs within a single firm. So you produce a variety of outputs within a single firm rather than having these outputs produced in separate firms. So let's say that you're a bank, and as a bank, you produce a number of a variety of outputs, but in one firm. In one firm. Okay. Instead of having subsidiaries and then letting each one of them produce different kind of products. So focusing on one thing in one place at a time, that is economies of scope.
Doc.
Yes.
Doc, I want to know, in the oil and gas industry, the situation where it has become clear that most states are trying to control both the exploration, then the production of the oil and the gas, and also selling. Can it be? Can it fall within this scenario?
Yes, it can.
Okay.
The only problem is that it's quite difficult to actually get data on the selling part and then the exploration part.
Okay.
You can get data much on the production, but the selling, it's quite difficult. They don't really, it's quite difficult. If you might get it even for one firm, fine, but it's quite difficult to get it for all other firms.
Okay.
And so what's such an analysis? So what you want to think about, all of you want to think about now, is that are there classifications in your industries? So when you take your industry of banks or the industry of oil firms or the industry of insurance, are there different groups of firms within the industry? So let's take, for example, bank, for example. Are there different groups? Yes. In the world of ownership, they are different. You have banks that are foreign owned and banks that are domestic owned. And even the foreign owned, you can classify them again as to those that are Nigerian foreign owned and those that are non-Nigerian foreign owned. And in the domestic, you can also even classify them as those that are state and those that are private domestic. So this is a typical example of classification. Now, in the world of oil, you can classify them as the same thing on the basis of ownership. Those that are private and those that are public. Okay. And then you can go the public, those that are public and multinational, and then those that are private and multinational. So you can have different classifications of these along the line. Okay, that's the types. That's the types. Okay, and in terms of production, that's what you said. You can look at those that are upstream, those that are downstream. You know, those are some things that people look at. Those that are doing exploration, production, and distribution. Exploration, production, or distribution, or those that are, you know, or separate ones of them. But the question is, if there is data there, it's good to look at these classifications. The key point of economies of scope is that there's a way you can calculate it. Oh yes, there's a way you can calculate this economies of scope in the world of our efficiency analysis. In the world of parametric frontier analysis, calculating them is difficult, but in the world of non-parametric frontier analysis that we are doing, calculating them is not that difficult. And we shall do that. But I want to refer you to a paper by Cummins. I think Cummins 2010. where he looks at economies of scale and economies of scope. In fact, one of you is going to do this, so it's quite important for you to look at that. Okay, economies of scale and economies of scope. So that's economies of scope. Output exists. It exists if the output can be produced at a lower cost, if you go diversified, okay, rather than specializing firms producing the output separately. So that's what economies of scale are. If we do it, in fact, that's the whole essence of universal banking. Okay, that universal banking, why isn't it possible that one bank can produce all of these things together? Okay, the banks will be doing deposits, will be giving loans, will be giving commercial. Previously, we have commercial banking, you will have investment banks, you will have savings banks, you will have, what do you call it? Agricultural banks. We have those things previously, but now they are universal because of economies of scope. The idea is that can they produce all the outputs, than, specializing in those ones. And that is the key essence of economies of scope. So economies of scope can even exist if firms are operating at the minimum cost, even when there is no scale economies. This is important, okay? And when you read a paper by Cummins, even when there is no scale economies, even when firms are not operating at a constant returns to scale, there is economies of scope. So economies of scope can occur in the presence of decreasing returns, increasing returns, constant returns. Okay, so that's how you want to look at it. Now, the next kind of efficiency you want to note, now we have finished the technical efficiency. Okay, we are finished. So as a way to just let you know technical efficiency, I'm going to write something here for you to get clear. Technical efficiency, we have looked at it in this way. It's made up of mixed efficiency. It's made up of pure technical efficiency. It's also made up of scale efficiency. And then we have also looked at something we call scope economies. Scope economies, that one is as it is on its own. Then we are now going to look at another kind of efficiency, which is known as allocative efficiency. And then we shall look at another kind of efficiency called cost efficiency. Please note that the cost efficiency is this technical efficiency you had there. This technical efficiency you had. Okay. Multiplied by the allocative efficiency. That is it. Multiplied by the allocative efficiency. So first, let's look at allocative efficiency. Okay. What is that? What is this allocative efficiency? Well, allocative efficiency on the cost side, and it's very important to understand because we have allocative on the revenue side. It's just making it opposite. Okay, it happens when you choose the wrong, of course, allocative inefficiency. Okay, but if I'm defining allocative efficiency, you say it happens when you choose the correct input combination, given the output prices, given the input prices. Okay, allocative efficient. You are allocatively efficient if you correctly select those combinations of input, given their prices. If you select correctly, because if you employ one person and bring 10 computers, you are crazy. You are crazy because one person cannot use 10 computers. He is not a machine. So it means that your selection of the inputs are wrong. You will see that eventually 9 inputs will be there and wasted. Nobody will use it. Eventually, the prices, would have been, useless. So your ability to combine the output. So that means that you got to know the prices of the input. And you have to combine them very well. That your ability to do that is allocative efficiency. It's very important to understand it. Practically, read the literature and get a practical understanding of allocative efficiency. So the inefficiency of a firm attributable to underutilization, okay, of resources or wasting of resources is what is known as technical efficiency. But then the inefficiency of a firm attributable to selecting the wrong combinations of inputs is allocative efficiency. So let's go back to the technical efficiency. We said technical efficiency is your ability to use the inputs, reduce them whilst maintaining the outputs. I want to repeat that. Technical is using the existing input. I didn't even talk about combining the inputs. I'm just saying using them. But once you are using them, you got to use them correctly. It's not a matter of minimizing the inputs, but it's a matter of minimizing all the inputs, but the input you are minimizing, are you combining them nicely? That is the allocative part. Technical part is minimizing the output. Allocative part says, whilst you are minimizing, are you combining them correctly? And that is the allocative efficiency. And if you are wrongly doing that, it becomes allocative. So in conclusion, these are the different kinds of efficiency charts that you want to notice and identify with. You want to notice profit efficiency can be split into two ways: revenue minus cost. That's why they are on the far flank, revenue minus cost. Or profit efficiency can be defined as technical efficiency multiplied by allocative efficiency. They are in the red section. Then, when you take revenue efficiency, you can just split it into technical and allocative efficiency, just like the profit efficiency. And when you take cost efficiency, you can split them into technical and allocative efficiency, just like profit efficiency. Okay. But on the cost section, you can also manipulate and also get something called scope economies. And on the revenue side, you can also manipulate and get scope economies. You cannot determine scope economies when we are talking about technical, but you can determine it when we are talking about cost efficiency or revenue efficiency. Now, under the technical, you can have pure technical efficiency, we've spoken about it, mix efficiency, we've spoken about it, and then scale efficiency, we've spoken about it. The question is, which kind of efficiency are you going to use for your analysis? Which kind of efficiency are you going to be